back in the game. So what do I have back here? Hey, these are the Internetworking devices. So some of them anyway, more relevant to your CCNA and some relevant to what you're actually going to see when you get out there. All right, so there's 4 devices that you really need to be concentrated on, or really 2 devices, but we'll learn all 4. 2 devices for the examination, but as you can see up here we have a router, pretty simple, a circle with a bunch of arrows pointing all over the place, right? Because it goes all over, right? Creates the path to the internet network. You have a switch, right? Router layer 3. When we talk about the OSI, you'll see. Switch layer 2. Hub, which we just saw, bad hub. We don't want hubs on our networks. And then we have a bridge. Looks like a half pipe, something a skateboarder would use, right? So we have a bridge. So let's talk about this. What devices do we use or we would like to use? Well, we already know, and we're talking about Ethernet. Remember, Ethernet is a standard that was created, an IEEE standard 802.3, right? That has an access method that is CSMA CD, which really is just first come, first serve, right? We're all listening, right? Carrier sense, we're listening for noise. You could have multiple access then, but if you have the collision detection, not 2 computers can actually be on the cable at the same time. All right, so that's the problem with Ethernet. So our job as Cisco professionals, as network engineers, we need to reduce the amount of broadcast, reduce the amount of collisions that exist on a network. And how, pray tell, do we do that? Well, we do that by segmenting, breaking up collision domains, making more collision domains. That sounds kind of like it's contradicting. Well, wait a minute, Laz, you want more collision domains? Yeah, I do. I don't want one huge collision domain. It's like having one classroom with 200 students. I'd rather have 5 classrooms and break those up. I don't know the math. We'll break those up. Let's say 100 students for 25 students in each. I'll make 100. We'll make it easy. Or 50 students if it was 200, right? See, I did the math. But you want to break that up. You want to break those collision domains. So the more collision domains you have, that's good. The more broadcast domains you have, that's even better. So that's what you want to do. That's the whole point. But you need to understand the devices that you're using. So let's talk about our little half pipe buddy down here, the bridge. I hope you can see that. I think you can. The bridge, its main purpose is to segment a network. The bridge is software based, so it's kind of slow. It is limited on the amount of ports it can have. Now I'm going to throw a term at you. And I'll briefly or loosely define it, but once we get to that particular part of the course, I'll go deep into it. I will, I promise. The bridge can only have one spanning tree instance. And just spanning tree, all it is prevents loops, switching loops at layer 2 or bridging loops at layer 2. So bridges at the beginning, we use bridging. That's why they say, software bridging, things like that. So it's slow, it's limited on ports. So we got rid of the bridge slowly. And that's where, we definitely got rid of hub. We done away with hubs. We don't want hubs. That's your shared collision domain. You only have half duplex, right? You can only send or receive. Here on a bridge, you have the full duplex using 2 pairs of wires, meaning you can send and receive at the same time because you're using 2 pairs of wires. That's a good thing. Where hubs, you're done. So hubs, it's pretty much over. We don't use them in the real world. Nobody does. Don't use them. Bad thing. Will they ask you something on the test about hubs? If they do, just know it's bad. Anything that says bad about hubs, that's the answer for hubs. All right? Or shared collision domains. Switches. That's where you're going to be tested on. That's going to be 20% of your grade and all the different things that you can do on the switches. What can you do? you can break up, well, each port on the switch, it's its own collision domain. So the more things you plug into it, so you have a 24 port switch or a 48 port switch, you have 48 collision domains. You have that full bandwidth. If it's a Cat5e, you have the 100 megabit per second, send and receive at the same time. If you have a Cat6, you got 1,000 megabits per second, send and receive at the same time. So you've broken up those collisions. That's awesome. It's a private collision domain. The only thing, you have still only one broadcast domain, which means when people are talking back and forth, regardless of what you hear out there, all right, they still hear that noise. They still hear that noise. So you still need to break up those broadcast domains. And guess what? That's what switches bring. Bridges bring in that segmentation. We want to break things apart. We have a group over here. We have a group over here. We use a layer 3 device like a router to intercommunicate with each other. But with a switch, we can break up broadcast domains at layer 2. How do we do that? By creating VLANs. We create VLANs down here, virtual local area networks. Now we can have multiple broadcasts on a switch. That is awesome, because what happens in the broadcast stays in that broadcast. So imagine this. You have, let's say a school, make things simple. Let's say on one side you have medical students and they're doing their labs and they're doing their things on the computer. And then right next to them, you have a networking class. And these guys, they're doing DHCP servers. They're doing all sorts of crazy stuff, security protocols, and they're trying to do hacking stuff. What's going to happen is if they're on one particular, because by default, and keep this in mind, this is something you should keep in mind. So when we get into that particular session, by default, all switches are part of VLAN 1. All switches are part of VLAN 1, which means we're all in one broadcast domain. So whatever I do on my VLAN, guess what? It's going to affect you. You're going to hear that noise. You're going to get slowed down. So if I have DHCP, what a DHCP server, for those of you that may not know or don't remember, all right, it assigns IP addresses. Or, I'll say it correctly, it'll lease IP addresses. Be careful with the terminology in the exam, because in actuality, or I guess, well, the reality of it is, that's what a DHCP server does. It leases addresses, right? We normally say assign. Everybody says assign. But the terminology that they play around with is that it leases addresses. Okay? Keep that open there. So if I have in that classroom a DHCP server and the school itself has a DHCP server, we're not going to clash with each other. I'll be assigning IP addresses to a classroom. DHCP server for the school will be assigning, so it'll be chaos. It'll be chaos because we didn't segment the broadcast domain, and we do that by creating VLANs. All right, so that's what the switch brings in. We can go ahead and have that extra functionality by creating those VLANs. Not only that, we can set up port security. We can create access lists. We can do what's called Ether channel. There's a slew of things that you can do now with the switches that we didn't do before. So definitely, switches is what you're going to have in your network. And if you're building a network in today's technology, if you're building a network from the ground up, if you're that lucky or you get to upgrade, you're saying, hey, let's go with gigabit, right? It was unheard of way back in the days of the bus topology and coaxial cable. And we're running 10 megabits per second or less. Those days are gone. Now we want fast. When I send you something, I want you to get it right then and there. The minute I click on that button, you should have it. Where's that information I just sent you? You don't got it yet? So definitely you want to get, if you're going to buy a switch, or you're doing things, you want to make sure if you're doing it on your own, right? If you're a consultant and this is your own business, or you're trying to convince your boss, listen, we have a lot of work. We need to be productive. In order for us to be productive for the size of packets that we're sending on our network, let's say I always use the example of guys that do surveying, because I worked with surveyors and they use these, AutoCAD. These AutoCAD files are huge, and they slow down the network a lot. So you want to use Cat6. So you got to look at your situation and say, hey, what type of device? Definitely, you're going to want to use switches. You're going to want to use switches. And key word here, you want to use managed switches. Managed. And what does that mean? Remember at the beginning that we were able to go inside a switch, put an IP address and a gateway and all that. So you can go inside of the switch and then configure whatever it is you need to configure. All right? So definitely switches, layer 2. Switches really only make a table. They create a table, what's called the MAC address table. But we'll get deeper into that. So that's a layer 2. And obviously the layer 3. This guy up here, the router, he breaks up broadcast domains by default. What does that mean? So if he has 3 interfaces, he's got 3 different broadcast domains, which means you have different networks. Different networks, meaning you have the 10, 10, 1, 0, 10, 10, 2, 0, 10, 10, 3, 0. So you have 3 separate networks all together. They can't talk to each other unless you're trying to get to it. Because the router creates a routing table saying, hey, where do you want to go? Oh, you want to go somewhere in the 3. I'll send you right back down where you were before. Because that's the way that works. And when we get to the routing process, you'll understand what I'm talking about. So depending on what you're doing is the device that you're going to use. But in today's world, the router and the switch are the 2 devices that are for sure you're going to have on your network. Now, I know these are symbols. These are symbols, so you need to understand these symbols, what they are, the bridge, the hub, the switch, and the router. But when you get out there, you're going to be working in racks. You know, first time I went out there and I saw a rack and I saw these patch panels. Let me see if I can zoom in on the patch panel so you can actually see it if you've never seen a patch panel. Because I know it freaked me out when I went out there. It's like, what is this? Because I went out there, I was like, I learned on the fly. Okay, I was, how do you say, I learned through fire or something like that. All these are patch panels. You want to have a centralized wiring system. All your switches, all your servers, all these routers, everything is going to be on this rack. Or it could be multiple racks. And all your wiring is going to come from your rooms into the back of these patch panels. And there's something called a crimper. You have strippers that strip the jacket off the cable. When we talk about cables, I'll show you those tools. And then you actually crimp the cable into the back of each one of these ports. And then you use a cable to patch it to whatever switch you're going to go ahead and plug it into. And that's how you make it. You're like remember in the old days, those operators that would connect your calls, they would go from here to here, here to there to connect those calls, like in the old days? That's what you're doing. You're bringing in the cables, you're punching them in the back of these patch panels, and then you're taking another cable, which is called a patch cable, and then you take it from whatever port to whatever switch on whatever floor or whatever department it is you're plugging it into. All right, and when we talk about cabling, I'm going to go very deep into that because you really need to understand, because this is the reality. This is what you're going to see out there. If you go do big networks, if you do a small network, medium-sized network, a lot of times it'll be in a closet somewhere. They'll have a switch in there. They won't even have a patch panel, and you just run in the cables from the switch to the computers, and that's it. I've seen that in many real estate offices. I've seen that in many medical offices where all they have is just a switch sitting somewhere, and they run all the cables from there to wherever it is that they need to. It really shouldn't be that way. One, you don't want your internetworking devices to be compromised. Because one of the things that people ask me, hey Laz, you have a router. Let me move this over here. See if you can see that again. Bring that back into the picture here. Right, well, let me go on this side. If you see, you don't have your router and your switch, you don't have them sitting in the front desk where people can, touch it, or they're somewhere hidden. You don't want it in the broom closet either with all the chemicals and, you got the people going in there mopping. You don't want that. You want your own little area where you're going to set your things at. Okay? So the reality of it, once you get out there, if you're not already out there, all right, is this. a patch panel, right? Yeah, you can see it right there. And you have your switch, you have routers. These are two different types of routers that we have right there. All right, and they all go interconnected to each other, all centralized right there. And you go down, I have a power strip. You have a power strip that you can put on the rack. You also have a UPS, important, very importante. You need to have a UPS. A lot of power outages. You don't want your things to go down. You need to get a UPS. Make sure. All right, so, but one thing we haven't talked about, and really in the new CCNA, they took that out, which is, you see here, my little wireless access point that Vizio has. All right, wireless is part of everybody's network nowadays. Everybody uses their wireless access point, as they call it, or wireless router. All right, to get out to the internet, you plug into your modem that takes you out to the internet, and you're wireless. Just be careful when you're using that, especially the placement of it. I don't want to get too deep into that particular one, but it is an internetworking device, and I don't want to get into a wireless. Just be very careful when you're doing wireless, because wireless is, one of the biggest problems with wireless is that it's unsecure. So you got to make sure you got to do your MAC filtering, and you got to disable the SSID. Now, I heard something or read something the other day that somebody posted. I don't know where it was. or it was read to me that that disabling the SSID, all it does is just hides it from the users, but it's still being broadcast, and that individual is correct. Yes, when you disable your SSID, that is your security set identifier. When you call it, Spartacus, or you call it whatever, the name, FBI, whatever it is that you want to call it. All right, don't connect to this wireless access point, whatever. That's what everybody needs in order to, you find one and you connect to it. And then if you secured it with some sort of, pre-shared key or whatever you're using, then you put in the password and now you're in. The SSID, even if you disable it and nobody sees it, yes, it's still being broadcasted. But in order for somebody to get it, they need to run special software on there. For homes, that's fine. For businesses, there's many different ways, which I'm not going to get into, but there's many different ways to secure a wireless network. Just doing the MAC filtering and disabling the SSID and putting pre-shared keys on there and little policies and whatever within whatever the router has, it's not enough. Even if you reduce the amount of power, it's not enough. But just understand that wireless is a part of internetworking. And the placement of it, which is what I was telling you originally, the placement of it is very important. Because remember, everything interferes with wireless. So wherever you put it, if you're putting it near fluorescent lighting, if there's brick or steel walls or metal file cabinets and all these different things, it could interfere. Are there more access points there? Are they running in the same channel that you are? So all these things, you gotta take a look, take into consideration before you go ahead and put it. The next thing I want to show you is, just point it out. Firewalls, obviously. If you deal with firewalls, you're definitely gonna have to learn how to configure firewalls. Whatever, there's 1,000,001 different manufacturers of firewalls depending on who you're using, so you can configure your policies. And then we have this thing right here, the glooming cloud, right? When you see a cloud in a book, all right, all it is, it's your provider, let's say. That's how I call it. This is how you get from one side to the other. So inside this cloud, you have mainframes, you have servers, you have routers, you have switches. So you don't worry about what's in here. When you're creating an internetwork and you try to get, let's say, from one location that's across to another, a wide area network, and you got to go through a provider, well, just worry about getting to the provider. And then the provider will do the rest to get you to the other side. All right? You just got to make sure you can get to the provider. All right? That's the thing. So these are internetworking devices that we have and we use on a daily basis. Real world is that rack that I showed you. Testing purposes, what you're going to really be focused on is really just these two right here, the router and the switch. We really need to focus, and we will, and learn the different parts. This guy breaks up broadcast domains by default. Awesome. This guy breaks up collision domains by default. And if you create VLANs, it will break up broadcast domains as well. So it brings in a lot of functionality. So these are your internetworking devices, and these are the devices that we'll be working with and that you'll be learning on how to configure them, how to use them, and how to place them correctly.